Hey folks, Quilly18 here, and welcome to another episode of Let's Program a Base Building Game in Unity. This is part of Project Porcupine. We've got two things I think we're going to tackle very soon. One thing is, people have started to ask me about saving and loading in the game, which is always a very big topic and a relatively complex topic because a lot of times it depends very much on your particular game structure. And I was going to say, you know what, it's too early, we haven't figured out everything quite yet for saving and loading, but I've actually realized that no, now would be the perfect time to do it. We have a basic structure of how our data is going to be maintained, so now what we want to do is probably take the time to implement saving and loading. That way we know that we've got that working in a sensible way, and then as we continue to add more data to our game, we'll make sure to construct our data in such a way that works well with our saving and loading. That being said, there's one more thing I want to tackle in Pathfinding before we do that. So saving and loading will most likely start next episode, but in this episode, we're going to tackle what is effectively just a little cosmetic issue here, which is to say, when we pathfind around, we cut these corners, right? And part of it is because our graphic is quite large, but definitely, I mean, as we move diagonally from here to here, we do visually sort of cut across there. And as a result, it looks a little bit silly, but it's not just that it looks a little bit silly, but it's easy to imagine a situation where our character should not be allowed to walk through here. And yet right now, you can, because you can move diagonally, and obviously that is a no-go. Whereas if I do cap that in, then we're no longer allowed to go over there. And I think it is perfectly fair to say that our character should not be able to squeeze through these areas. Also, there seems to be an issue with the job queue here. Oh, are we actually generating errors? Because I was going to say he can't do this job, and I think that's what he's trying to do. And then is he trying to put it back on the queue and we're getting an error? We're going to investigate that, because what should happen here is our character should not be able to reach this job. And right now I thought the way it would work is you take this job, attempt to pathfind to it, can't reach it, and then reinsert it into the job queue, which should put it at the bottom, so then it should grab the next queue, or the next cube. It's not necessarily the optimal way to deal with that problem, but it actually should be working right now. So there's a couple of things. One, we want to adjust our job queue mechanic here, and two, we want to block the diagonal motion, because one, there's a cosmetic issue, but two, there's an actual gameplay thing in that you shouldn't be able to squeeze through this sort of structure right over there. So we're going to tackle that in this episode here, and then we'll, I believe it'll only take the one, and then we'll start on saving soon. Anyway, without further ado, let's get going. So first of all, what is this error over here? Now, what's annoying with these errors here, when it's an error that something is trying to be inserted, or something with a collection, you can't double click on it and go to it, because the actual error being thrown is from inside a library of code that we don't have access to. So you actually have to go and look at the description down below to find exactly where it is. So you can see here in dictionary.cs, at line 404 is where the error is being thrown, but we don't have access to that. But the thing that's calling this is job sprite controller at line 30. That's interesting. Job sprite controller is what's causing the error. Really? At line 30. I think what is happening is when our character... So our character gets a job, right? We don't have a job. Find a new job. Job is not null. Excellent. We register the on-job ended, or completed and canceled callbacks. That's great. Are we there yet? Where do we actually do the pathfinding? We do the pathfinding here. There we go. Okay, so what's happening, I believe, is that when the... Oh, that makes sense, isn't it? So if we try to pathfind to a job, and we can't because it's behind a wall, which is fair. Actually, let's check the thing. It says, yeah, return no path to destination, which is fine. It then calls abandon job. And if we take a look at that, that just enqueues the job. Enqueuing the job calls the job created callback. So the problem is, job created, this callback is being created for a job that's already been created. Right? Are you following? When we create a new job, we want to be able to call those callbacks and let people know that things are going on. But and that's by default happening when a job is enqueued. But it's not being created a second time. It already exists. So this isn't accurate. This callback should be called job queued callback, which is very different from a job created callback. So what do we want to do about that? I mean, what we can do here is very simple. We can put in a little check. If it's already been created, then we could bail out of here. Or we could delete the old one. That actually might not be a terrible idea. And then just recreate it, because then we'd still go through all the setup. Although this should all be very accurate. For now, if dot contains key job debug.log error. We'll just log it, and then we'll see about fixing it later. On job created for a job sprite that, or job game object that already exists. Most likely job being re-queued as opposed to created. So this is sort of a fix me kind of thing, but this is all happening. So all we have to do is we just return right away because we assume it's okay. We're gonna have to fix this in a better way later on. Either just literally just renaming some of the functions so it's more clear, or making the job creation a two-step process or something of that nature. So let's get a pathfinding test up. Let's build a wall here, then over here to get you out of the way, and then there, and then over here. There we go. Lovely. Because what we have is right here, we are so we don't find a path to the destination, which means we're requeuing the job, which means the on job created gets called a second time, which is inaccurate and not necessarily what we want going forward. But for now, we catch the error, and at least it no longer breaks the program. So now it will try these, and then it's going to requeue them at the bottom, which is something else we don't want to do. Right now, it's requeuing these jobs to the bottom of the job queue, which means not necessarily what we want. We probably want to keep those older jobs at the top of the queue, depending on how we decide to search the jobs. And I think part of the issue is that our job queue right now, this is sort of a placeholder class. So we'll move forward. We're gonna change this up a little bit because basically it's just a very thin wrapper on this, and we're talking about the idea of having job queues per room and all kinds of different things. So I think the very mechanic of the job queue right now, it's not broken, so it's gonna be good enough. Okay, so the next thing we want to do then is just tackle this diagonal movement thing. And how do we block that? Well, what I don't want to do, there's two places we can make a change, right? There is inside of tile our code that returns the list of neighbors. Right? We could ask it to return neighbors without diagonals. But I don't want that, because generally speaking, diagonal tiles in our pathfinding system, right, in terms of walking around, generally speaking, diagonals are legal. They are a fine way to move. The exception is this. The time when we don't want to be able to move diagonally is when a tile... So let's say moving from here to here, right? So we'd be moving northeast. So we don't want to allow a northeast movement from here if there's a tile to our north or to our east. In this case, if we tried to move from here to here and we have a tile to our north, then it would ban this diagonal. We'd still be able to get into this tile because we'd be able to come in from the south and just go directly north into it. And that would be fine. But in the case where we have a wall right here, then now we can't go northeast because there's a tile either to the north or to our east. In this case, there's both. So it doesn't allow that. And there's actually no path that would allow us to get to this tile, which would be accurate because we shouldn't be allowed to walk through here. So there's two ways. Yeah, there's two ways we can tackle this. We can change get neighbors in some fashions. Some fashions? Yeah, that's excellent English. Which might not be a bad idea. Like get neighbors, like another variant for a pathfinding. So sure, diagonals are okay, but maybe like a no squeezing or something like that. Send it a second flag, and then it can check its neighbors. The alternative is in our pathfinding code, which is our tile graph. When we generate our tile graph and it calculates the edges, the first thing it does, we get all the nodes, and then over here we create all the edges based on neighbors where diagonal. In here, what we could do is do a check, right? We check to see if the neighbor is walkable, but what we could also do in here is check, again, if this neighbor is like northeast, then we have to check adjacent neighbors, like the one to the north and the one to the east, and then maybe not create an edge. I think it's sort of 6 of one, half dozen the other. I feel like putting it here would actually lead to a little bit more overhead and a little bit less clarity, whereas we're already doing here. We have to add an extra flag here called squeezing OK, which defaults to true. And we could go and put a nice little is diagonal movement OK? Is clipping corners, actually maybe we'll call it clipping, slash squeezing diagonally, okay. So a lot of times when we want neighbors, we really want the true count of neighbors, which means that diagonals and clipping movement and all those things are going to be fine. But our pathfinding system over here in our tile graph will actually ask for one where clipping around corners is not okay. So then all we do is we come back here, and it's just in the diagonal code, right? So this is northeast. So we get the tile, which could be null. So what we need to do is like wrap each one of these around another check. So if clipping is okay, then obviously we're going to process this no matter what. Else, yeah, if clipping is okay, we're trying to come up with an error state. If clipping is okay, then we don't care. Diagonals are always going to be fine. But if it's not okay, then we have to do an OR, where we check to make sure that the other tiles are all good and walkable. See, here we don't actually check for walkability. Here we check for walkability, so it sort of feels... You know what? I think I'm changing my mind. I think I am changing my mind. We're going to get rid of this. I'm going to put it here, because this is where we actually check for walkability, and it might make more sense to keep everything in the same area. So, so the neighbor exists and is walkable. Let's put in another check over here. But first, make sure we aren't clipping a diagonal or trying to squeeze inappropriately. So, if I'm getting increasingly unhappy about this. I think that no matter what, we're going to end up with awkward, annoying code. Let's make a helper function. Is clipping corner. So we want the current tile. So we get tiles here, right? Cur tile nay for neighbor. So if the movement from cur to nay is diagonal, example, northeast, then check to make sure we aren't clipping. E.g., N and E are both walkable. There we go. So we'll put the logic out that way. So if is clipping corner from our current tile, which is, it's been a few days since I wrote this code here. Our current tile is T, and our current neighbor, which is a series of tiles, is neighbor I. There we go. Then we just continue. Skip to the next neighbor without building an edge. There we go. All right, I'm liking this logic. I'm feeling better about this than when we were messing around in here. I feel a lot better about this. So, is clipping corners. So, the way we check to see if something is diagonal is by checking to see if the difference between their coordinates is effectively 2. So, we've looked at something like this before in some of our distance calculations over here, for example, right? So, if current dot x minus neighbor dot x is equal to 1, right? So that'll guarantee that they differ in the horizontal axis, but we do want to make sure to grab an absolute here because this could end up being +1 or -1, but by putting it absolute, it'll guarantee that it ends up being +1. If that plus mathf.absolute current.y minus neighbor.y. So if those two added together comes out to exactly 2, we are diagonal. Now, this is because we know for sure that we're checking neighbors. So this will never result in, +2 or something like that, which would change the numbers. So this is going to be fine. So the way we check for clipping is to say in the direction that we're going in. So let's get an integer here because why not? So we'll call it dx. So the difference in x, and here we don't want the absolute number. We want the actual direction. Is that actually? I guess we could pre-calculate this stuff before we do this math here. It's slightly more optimal, but who cares? And the difference in y is cur.y minus na.y. So if our neighbor is to the south, then this would be -1, which is okay. We want to check that. So we know we're diagonal at this point. We just want to check to see if the tile at this point, so if this is a northeastern example, if the tile to our north and the tile to our east are both walkable. So or rather, we sort of want to check to see if they're not walkable, and then we can return false at this point. Because we're going to assume at the end we're going to return, we're going to assume we want to return false, in that the corners, that this is perfectly fine, we're not clipping a corner. So either we're not diagonal, in which case we can return false, we're not clipping any corners or whatever. And at this point we want to check to see, there's a possibility here we would return true, and we'll return true if we grab the tile. So we don't have a reference to the world. Well, we actually do over here, but we can also get that from the tile. So if current.world.getTile at, so we're going to get from our current tile, current tile.x, and we're going to add the x difference, and then we're going to use our current y. So we're checking the tile, depending on what kind of diagonal movement we're looking for. We're either looking for the tile directly to our east or directly to our west at this point. If that tile's movement cost is equal to 0, then east or west is unwalkable. Therefore, this would be a clipped movement. So return true. And then we do exactly the same thing and we could do else ifs here, but it literally doesn't matter at this point. So we stay on the same x, so effectively here we're going to be checking either our neighbor to the north or to the south if it's unwalkable. So north or south is unwalkable, where this would be a clip movement. So let's see if we've made any syntax errors, first of all. No, we haven't. Let's check to see if we've made any logic errors. Get our testing. Can we move over here? Yes, we can. Can we move down here? Yes, we can. Let's move over here. And let's try to wrap around the corner. No! Well, that was interesting. Is it semi-working? Something was definitely still getting clipped. I must have done a simple little typo or something in my code here. Okay, so the quick correction was just inverting the signs over here. Instead of adding the difference, we subtract the difference. I guess that's pretty classic for me for the movement. But for a neighbor, if this is higher... Oh, yeah, that does make sense, actually. So in this case, if the wall is to our north, and our north is positive y, so if we're trying to move north, then current y minus neighbor y would lead us to have a -1. And then if I'm trying to compare here, so I would have been doing current y plus -1, which means I was actually checking to the south. So I had my sign inverted here. That's the issue. And like, it didn't feel like a big problem. Just a slight sign inversion. So let's go ahead. And let's try the pathfinding test. So now if I say I build a wall here, build a wall over here, that looks right. And if we send you way down here, you can see here, we are no longer moving diagonally through there. And if I move all the way over here, we can see diagonal movement still happens, but not through doorways. So yeah, I just had a sign inverted. Good. Okay, I'm happy I didn't have like a horrible logic failure going on. Like my entire approach was completely broken and stupid. It's not the case at all. Oh, I like that. You see, he doesn't move to here and then go down that way and then here. It's much faster for him to go diagonally there. Saves him a little bit of movement by taking advantage of the diagonals. Yeah, excellent. Wonderful. And let's confirm, actually, that you can't move through this diagonally. And you can't. And that's all working perfectly well. Lovely. Go there, then come back over here. And then try to go there. You'll pathfind all the way around there. Nice. Nice, 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 nice. Come down here, then go over there. You work your way around all this stuff. Oh, all right. Okay, that looks better. I think it's definitely an improvement. So this here again, more verbose than always, and wasted a little bit of time with that sound inversion. But that's the common sort of stuff that you actually spend a lot of your time trying to figure out in programming. It's a tiny little error that's easy to do and very hard to spot. But there we have it. So yeah, we make sure that we've got a neighbor, and the neighbor is walkable, and it doesn't require clipping things in an awkward way. The tile code is simple and still just correctly returns a list of neighbors, so this doesn't try to get too fancy. And it makes sense that it's here that we are trying to determine the walkability of things, and we care about movement cost, and we put those rules in here later. Because later on, we could have something that maybe it's allowed to go diagonal because of other things. Like, I don't know, maybe a little worm that can clip corners or some damn thing, I don't know. We might want to change some of these basic walkability rules. Actually, the movement cost changes considerably. For example, what if we have a flying unit, right? So right now, if we have, say, like a big, deep pool of water, that is not walkable. Therefore, we can't pathfind across it, but also we'll avoid clipping corners around it. But if we are doing this code for a bird, a flyer, well, our movement cost rule changes slightly. In fact, the way we ask if something is movable will probably change. We'll have some other little function where we send in movement flags or something. But then the entire basis of whether something is movable or not depends on who's asking for a pathfind. So here, when we create a tile graph, we're probably going to specify, we're going to make one tile graph for people who walk and one tile graph for things that fly, and then they'll use slightly different rules here for determining walkability and whether we're clipping a corner, and that makes sense, whereas our tile code doesn't care about all that. It just returns a set of neighbors, and we can get rid of this squeezing OK comment. I'm really happy about that. Okay, so now that we've done that, because that was it looked ugly. The clipping corners looked ugly and stupid. We can set aside pathfinding for a good long time now. I am going to see if we can write some saving code next time. We've got a couple of different approaches for it. We could use the C# serialization code to do that, but I think that really wouldn't be the best approach for what we're looking to do here. So I think we'll end up writing just a little bit of custom saving code, custom serialization code. I will still use a lot of the built-in libraries. Probably we'll do something like save to the XML. Using the built-in XML formatter, because I like making save files in plain text. Who cares if someone can go in there and edit and cheat or whatever? It makes it a lot easier to debug. And honestly, if you're worried about it, you could still save to XML and then zip the XML file to save space, because text files are large. But if you zip the XML, that'll save a bunch of space. And then, of course, you can always put a password on the zip. And you can do that all in code if that's something we want to do. But I think we'll have a nicer time if, especially as we develop, we just save to a text-based format. There's also a really good JSON library that we can consider using. It's not built in, but we could go ahead. And you're stuck. but we could go ahead and use that. I think I'll use the XML. In any case, thanks for watching, folks. See you next time. Thank you very much to all our January supporters over at patreon.com/Will18Creates, and these Mic Check supporters. We've got Alexander Gutler, Andre Odendal, Neil Blakely Milner, Speedy Savant, Valiant Cake Fiend, Aaron Toyson, Marius Field Vold, Disco Geek, Ole Peter Talgo, Julian Auger Lafont, or Auger Lafont, I should say, Steven Stagger, Michael McClintock, Kale the Quick, Drazion, Wes Oldenbeving, Craig Mortel, Nail or Nale, I don't know, Vikstrom, and Andrew Henninger, and everyone who has watched, shared, favorited, and subscribed to these videos, and left comments as well. You guys really keep things going. Thank you very much for watching.